Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to discuss Section 7 of Chapter 7, Factoring Special Cases of Polynomials. So when we talk about special cases, we are talking about a consistent rule that can be used to factor certain types of binomials and special trinomials. Now, if you want to follow those rules, then you can read through the first part of the notes. However, I'm going to show you how to consistently use the trinomial method that we have been to factor these special cases. So if we look at problem 1, number 1, we want to factor x squared minus 12x plus 36. What I'm going to do, I'm going to multiply the number in front of x squared, which is a 1, with my constant 36 to get 36. And I'm going to think of any two numbers that multiply to 36 that add to negative 12. So that would be negative 6 and negative 6. Those are the two numbers that will multiply to 36 and add to negative 12. Once I have my two numbers, I'm going to rewrite my trinomial as 4 terms, replacing the 12x with minus 6x minus 6x. And then I'm going to break these 4 terms into 2 binomials. I'm going to factor each one using the GCF method. So on the left, I'm going to factor out an x and then be left with x minus 6. On the right, I'm going to factor a negative 6 and be left with x minus 6. What we got on the inside matches, which remember is what we want to happen. So my first binomial is x minus 6. My second binomial I'm getting from what was out front, x minus 6. So since I'm getting 2 of the same binomial, when I write this final answer, I'm just going to put a squared symbol. You could write x minus 6 and x minus 6, or you can just put an exponent of 2. So if we look at number 2, we want to factor x squared plus 6x plus 9. So for this one, same process. I'm going to factor the number in front of x squared, 1, with my constant 9 to get 9. And I need two numbers that multiply to 9 that add to my middle number, 6. In this case, that's 3 and 3. And what I'm going to do, I'm going to rewrite my trinomial as 4 terms. X squared plus 3x plus 3x plus 9. I'm going to split it to 2 binomials and factor by GCF. So on the right, or on the left, I'm taking out an x. On the right, I'm taking out a 3. The insides match. I have x plus 3 left. So x plus 3 is my first binomial. And what's out front? The x plus 3 would make my second binomial. Now, since it's the same as my first, I'm just going to say that this would have been x plus 3 squared as my final answer. So you try B, see if you can factor x squared minus 14x plus 49. If you factored B correctly, you would have gotten x minus 7 quantity squared. That is a 2. Or again, you could have written x minus 7 times x minus 7. The other type of special case we want to look at is called the difference of two squares. For these problems, we're going to have a binomial that we want to factor, but I'm going to treat it using the same process as I would a trinomial. So in number 1, we want to factor z squared minus 9. So I'm going to take my number in front of z squared, which is 1, and multiply it with my constant negative 9 to get negative 9. Now in this problem, I do not have a middle term. So if there's no middle term there, that means it's a 0. So I'm going to need two numbers that multiply to negative 9 and add to 0. That would be 3 and negative 3. So when I rewrite this, it's going to be z squared minus 3z plus 3z minus 9. I'm going to split it and factor by GCF. Take out a z to get z minus 3. Take out a 3 to get z minus 3. My insides match, so my first binomial is z minus 3. My second would be z plus 3 because there's a positive 3 on the outside. So this one would factor to z minus 3 and z plus 3. If we look at number 2, v squared minus 100, I'm going to multiply the number out front times the constant, which is negative 100. And I need two numbers that multiply to negative 100 and add to the middle term, which would be 0 since this is only a binomial. So this would be 10 and negative 10. So this would be v squared plus 10v minus 10v minus 100. Split it to two binomials and factor by GCF. Negative 10's coming out on the other side to leave me with v plus 10. Insides match, which is what I want. So this would factor to v plus 10 and v minus 10. So you try B. See if you can factor s squared minus 16. If you did it correctly, you should have gotten s minus 4 and s plus 4. In problem 3, we're going to continue factoring difference of squares. For these problems, I'm going to use the rule. That way you can see how the trinomial method works versus just using the rule. Because the bigger the numbers are, the quicker it is to use the difference of squares rule. So number 1, we want to factor 16x squared minus 81. So when I'm factoring a binomial, if they do not have a GCF, which 16 and 81 do not, what I'm going to look for is see if my two numbers are perfect squares. 16 is a perfect square, that would be 4. 81 is a perfect square, that would be 9. So when I factor difference of two squares, I just take the square root of each term and write my binomials. So 16x squared would be 4x, of 81 would be 9. One of the binomials gets a plus, and one of the binomials gets a minus. If you compare this process with the longer method we did in problem 2, you'll see it works every single time. So a difference of two squares, if we just take the square roots of each number and plug them in with a plus and a minus in each binomial, it will save us the process of factoring by GCF on both sides of a larger polynomial. So let's look at number 2. We want to factor 25d squared minus 64. So I could multiply 25 and 64, get a large number, and try to figure out what multiplies to get that and also adds to 0. Or I could use the rule. 25 is a perfect square, that would give me 5. 64 is a perfect square, that would give me 8. So if I factor this, the square root of 25d squared is 5d. I want a minus 8 because that's the square root of 64. And I want another binomial where I do a plus 8. And that would be factored. So if you have perfect squares and it's a binomial that's being subtracted, use the shortcut and just take your square roots. Number 3, 25d squared plus 64. First thing you do is look for a GCF. 25 and 64 don't have anything in common, so then you want to try to factor. The only way to factor binomials is by GCF or difference of squares. We already eliminated that this does not have a GCF, so we could only use difference of squares. However, this has a plus, and a plus is known as a sum. There is not a possible way to factor a sum of squares if a GCF is absent. So whenever you have a sum of squares, if there is no GCF, we call that prime. Because we're not going to get two numbers that multiply to a positive, but also add to a 0. Our last problem, we're going to tie in the ones that have GCFs and look at factoring those. So number 1, we want to factor 24g squared minus 6. First thing that I'm going to do is factor out the GCF of 6. That will leave me with 4g squared minus 1. Remember, once you factor out a GCF, see if what's left can be factored. This is a difference, and I know that 4 and 1 are perfect squares. So I'm going to factor this, keeping the 6 on the outside, to 2g, because that's the square root of 4, minus 1, because that's the square root of 1, and 2g plus 1. Number 2, when I factor 12t squared minus 48, I'm going to first take out the 12 to be left with t squared minus 4. And then I want to see if what's inside can still factor. T squared and 4 are perfect squares, so I'm going to break this down even more. T minus 2 when I take the square roots, and t plus 2 when I take the square roots. Don't forget there was a 12 on the outside that we need to drop back down. Lastly, I'm going to factor b. First thing I'm going to do is take out my GCF. They all have a 3 in common. So I have 4x squared plus 4x plus 1. I want to factor this trinomial as much as possible. So I'm going to multiply 4 and 1 together to get 4. And I need two numbers that multiply to 4 that will add to the middle number 4. That will be 2 and 2. So I'm going to rewrite this as 4x squared plus 2x plus 2x plus 1. Split it to my two binomials and factor by GCF. I can take out a 2x to get 2x plus 1. On the other side, I can take a 1 to get 2x plus 1. Insides match. So I have 2x plus 1. The outsides would also give me 2x plus 1, so I'm just going to write an exponent of 2 rather than write it again. And don't forget we took a 3 out at the beginning, so stick that 3 right back on the outside. This concludes our lesson on being able to factor the special cases. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.